physical virtual path is required here for two customer, two, right?
Two paths.
We can have two physical cable or we can have two virtual network. We can configure VPN, we can configure BGP, we can configure OSPF, right? For an example, I have sub interface dot 1 and f0/0.2, and I am going to assign this to VRFA, this to VRFB. Now this link, this port is going to carry traffic of VRFA between P1 to P2, and this port is going to carry traffic of VRFB between P1 to P2. But guys, if I have a single link over here, in that case what will happen? You have to configure two routing protocol here. If you are running OSPF, through OSPF you are exchanging the route, then you have to enable OSPF on f0/0.1 also, f0/0.2 also, right? Here I can enable OSPF, I can configure a static route, I can configure EIGRP, BGP, any protocol. But two protocols are required. One is going to carry VRF-A traffic, means customer A traffic. Another is going to carry customer B traffic. But what
Sir,
if
but
I have...
agar same, sir, if you would have used OSPF only between PE on two interface, sub interfaces, that is also possible, right?
Yeah, that is also
Because we are
possible.
dividing it in, because we are dividing it into VRFs,
Yes.
basically both the interfaces.
हाँ, सेम प्रोटोकॉल चलाओ, डिफरेंट प्रोटोकॉल चलाओ, कुछ भी चलाओ, doesn't matter,
Okay.
right? The concern is one interface here I have to assign for VRFA, one interface I have to assign for VRFB,
B.
right? And
Correct.
now I have two interfaces in VRFA on P1, so they can communicate. I have two interfaces for VRFB on P1 order, they can communicate, right? So customer can
Correct.
advertise same subnet or different subnet. Doesn't matter if both the customer is advertising same 10.1.1.0/24. No problem, because we have separate routing table over here and
Correct, sir.
separate path is there between P1 to P2. Separate path is also there, right? When problem will occur, guys, when we have single BGP neighborship, what we have seen in the BGP configuration, that between router 1 and router 2 doesn't matter how many paths are there, right? By creating one loop back over here and one loop back over here, 2.2.2, we can form the BGP neighborship. Guys, why we need to configure single BGP here instead of configuring multiple BGP or multiple OSPF or multiple EIGRP or configuring a static route? If I have two customers, then there is no issue. We can divide this single physical interface into two sub interface. But what if I have lots of customers here? If 50 numbers of customers are there, then it is going to be complicated, right? You are not going to
With the
create
physical
50 number
interface, I
of
think.
sub interfaces there.
Correct.
Its CPU utilization of your router will reach to 100%. So that is not practical. So here we will have single BGP neighborship and we are going to advertise the prefixes of both customer A and customer B, means VRFA and VRFE. This is similar like trunk link. Similar like trunk link which carry traffic of multiple VLAN. In this case, if both the customer are advertising same IPv4 subnet, right? Now on this link between P1 to P2, we cannot differentiate the prefixes. Which prefix belongs to customer A, VRFA, or which prefix belongs to VRFB, customer B. Right, guys? Here, if I have two multi-layer switches are there, and link between switches trunk. This link is trunk link, and here I have two VLAN traffic. Trunk, and here two VLAN traffics are there, VLAN 10 and 20. Can anyone tell me how switch 2 will identify the VLAN ID after receiving traffic on the trunk link? This is in VLAN 10, this is in VLAN 20. VLAN 10.
Tag values.
Sir, switch forwards the traffic on the basis of tag values.
Whenever switch will forward traffic on the trunk link, it will add tag value, right? So if switch 1 is receiving traffic on VLAN 10 interface, right, on this interface which is member of VLAN 10, then it will add VLAN 10 tag on the trunk link. And when switch 2 will receive traffic on trunk link, first it is going to check tag value. If tag value is 10, that means this traffic belongs to VLAN 10. If tag value is 20, that means this traffic belongs to VLAN 20. Right? Similar things required over here between P1 to P2. We have to do something so that P2 router can understand whatever prefixes I am learning through BGP. Here I am learning BGP. Whatever prefixes I am receiving, learning through BGP, I have to identify this prefix belongs to which VRF.
Correct.
Right? That's why we have what? That's why we have RD value, route distinguisher value. For each VRF, we are going to add route distinguisher value.
That is a tag only.
Tag only. Yes, tag only. That is similar like the VLAN tag. That is similar like VLAN tag. Right? If I will talk
So,
about
sir,
the length of
RD,
RD, yeah.
RD is going to be specific for every prefix, or is it specific for every VRF?
Why for prefix, brother? How you can add the RD value with prefix? To P2, no, the 10.1.1.0/24, no. It only know the VRF, right? So where we are, to whom I will assign RT value, guys? To VRF only, right? And automatically with all the prefixes which belongs to that VRF, all the prefixes which belongs to that VRF, RD value will be added automatically, right? So RD is nothing but 64 bits decimal value. What's happening? It is 64 bits value that help to differentiate the customer prefixes or VRF prefixes, which helps to differentiate customer prefix, or you can say overlapping IP addresses between the customer, right? So here I am saying, let's say VRF from this different customer. Your RD value is going to make sure that what, that two customer is using same IP address. RD only allow multiple customer to use same IPv4 subnet, even though they cannot conflict on the P router. Otherwise, if we don't have RD value, then two customer cannot use same prefix.
So, sir, RD is required basically to enable the BGP in this scenario, right?
No?
Agar OSPF would have been running between P1 and 2
Yeah.
with a physical IP address, that would have been possible without RD-RT like we did it in
Hey, what I am
VRF Lite,
saying,
right?
trying to told you that RT value is used to differentiate the customer prefix, not for BGP. If two customers are using same subnet, then how we can differentiate them on the P router with the help of RD value? I am going to define RD to VRFA 1:1 and RD to VRF2 2:2. Now we can differentiate the prefixes. Whatever prefixes P1 router is going to receive for VRFA, it will add 1:1. So prefix over here is going to be 10.1.1.0 1:1, and here 10.1.1.0 2:2. So now both are different prefixes. So it is used to avoid conflict of customer IPv4 subnet whenever customer using same IPv4 subnet. It is not going to affect any routing, right? This is not the part of BGP or something else. This is just to differentiate the customer prefixes.
But sir, that we have done already through differentiate through VRF, right? We have already done it
Through
yesterday,
VRF,
last
what we
class.
through VRF we divide the routing table of router.
Correct.
Now there are two routing table on this PE router, but PE router is going to advertise both prefixes VRF A, VRF B to PE2 na. How PE2 will
Mm-hmm.
get to know that which prefix belongs to VRF A and which prefix belongs to VRF B? See here the example. Guys, is we have tag value for OSPF here, VLAN tag. Is it for OSPF protocol? Is it for BGP protocol? No. Why we have tag value here? Just to identify the VLAN. Similar way here we have RD just to identify the customer prefixes.
Sir, it can be used as a import and export.
That is also different thing, brother.
RT is there for that.
Guys are self con I use.
सर मेरा कहने का मतलब ये था कि हमने जैसे VRF लाइट करा था, करेक्ट?
VRF लाइफ में RD
तो
की जरूरत नहीं है.
हाँ, तो
अरे
व्हाट
अगर
इज द
हमारे
नीड?
पास P1 और P2 के बीच में एक लिंक है जो ये VRF A में है और VRF B में है, तो हमें जरूरत ही क्या है RD की? डिफरेंशिएट करने की जरूरत ही क्या है? फिर तो ये दोनों पोर्ट ऑलरेडी कनेक्टेड है, ये दोनों पोर्ट ऑलरेडी कनेक्टेड है, ये कस्टमर बी के लिए दो पोर्ट ऑलरेडी कनेक्टेड है, ये पोर्ट ऑलरेडी कनेक्टेड है. कहाँ पे नीड है VRF की? कहाँ पे कॉन्फ्लिक्ट होगा प्रीफिक्स?
सो
प्रीफिक्स
यू आर
तो तब
सेइंग दैट
कॉन्फ्लिक्ट होगा ना जब सेम ही लिंक पे जाएगा दोनों सबनेट.
Got your point, sir. Got clear. Thank you.
So in this case, sir, between two PEs, only one link is there. No sub interfaces, right?
And we know how many links are there, but we have only one BGP neighborship. And same BGP
this
is
is
going to carry VRF A as well as VRF B prefix. Only single BGP is going to carry traffic of all the VRF. If I have 50 number of customers and they all are using same IPv4 subnet, no problem, right? For each VRF, we have defined a unique RD value that will make their prefixes unique. And now BGP can forward it to another P can understand it by checking the RD value.
So RD is required when there is a shared link. If there are dedicated links, so we don't need RD.
Yes. When we have dedicated link for all the VRF, then RD is not required. That particular thing is called VRF Lite. We have already seen in last class.
Means instead of creating number of sub interfaces, we can do it differentiate by adding RD to that IP address.
RD
Got
is
it.
just a tag value for the VRF. Okay. And another
So,
thing,
sir,
yeah.
so sir, PE2 will see the RD value and then it will inject that route into its specific VRF, correct?
No, it will get to know that this prefix belongs to this particular VRF.
It will
Okay.
forward that route to the specific.
How R2 is going to inject VRF A prefix to VRF A on P2 router? For that we have RT value, another term, right? Even you can achieve route leaking as well. Now, while advertising prefixes from P1 to P2, first of all, we have differentiated the prefix for both the VRF, and now I am going to advertise it to P2, right? So this BGP is going to carry two subnet, 192.168.10.1.1.0, 1:1, and another prefix is 192.168.10.1.1.0, same subnet, and 2:. Right, BGP is going to advertise these two subnet to P2 router. When P2 router will receive it, P2 router is going to check the RT value, not RD value, to understand where I need to inject it. Right, router 2 need to understand what, in which VRF I will insert this prefix and in which VRF I will import this prefix, right? So we are going to add one more value over here, that is again 64 bits value, which is called RT, route target. Route target. So for an example, here I am saying for VRF A, RT value is 100 ratio 100. RT value 100 ratio 100 export. So you will always export RT value 100 ratio 100 for VRF A. And now on router number 2, I am going to say import RT value 100 ratio 100 in VRF A. If I will say import 100 ratio 100 RT value in VRF B, then guys, customer A side 1 prefix will be injected in side 2 of customer B, not in side 2 of same customer. So whatever RT value I am going to export from P1 router, same RT value I will import on P2 router in same VRF. In the similar way, when P2 router will advertise prefixes to P1 router, whatever RT value I am going to export from P2, same RT value I will import in VRF A, same VRF. Whatever RT value I am going to export from P2 for customer 2, same RT value I will import over here. So that customer A side 1 prefix can reach to side 2 of same customer, and customer B side 1 prefix can reach to side 2 of same customer. When you need route linking, let's say later after few years, both the company are going to merge some services. They need to communicate, right? So we can, whatever RT value I am exporting over here, same RT value I can import in VRF B. Automatically prefixes will be injected over here. Getting my point? So in
Sir, I have
MP-BGP,
a confusion.
we have these
Sir, I
two.
have a confusion here again, sir, if you could just allow me. So if all these imports and exports are being done on RT value, route target value, so what is the use of RD then?
RD is used to differentiate the prefixes, brother. Differentiate the RD is similar like your tag value.
On the local router, basically. RD is for local router.
RD
No,
is
but on
similar like
local
VLAN
router,
tag.
there is already VRF. There on local, there is already VRF, so we don't need RD.
Don't need RD. Here, how you will tell to your BGP that this subnet belongs to company A, VRF A. BGP is running between P1 to P2. How you are going to tell to BGP that this subnet belongs to VRF A? How BGP will get to know that?
सर वो वैसे आप IPv4 for routing जैसे like we did it in EIGRP or OSPF
नहीं, BGP
वैसे भी
में
तो हो सकता
BGP में जब आप दोनों नेटवर्क यहाँ पे
एड्रेस
P1
फैमिली
के एड्रेस फैमिली, तो एड्रेस फैमिली हम लोग BGP में MP-BGP नहीं ना यूज करने जा रहे हैं. We are not going to use address family here. We are not going to run BGP for VRF A and VRF B, brother. We are running single BGP for both the VRF. If you are
Now I
running two
understood, sir.
VRF, one for two BGP, one for VRF A, one for VRF B, then RD is not required, na?
then there has to be two links between PV and PE1 and PE2
एक ही लिंक के ऊपर में नहीं हो सकता है. यहाँ पे एक और लूप बैक क्लियर कर दूँ 10.10.10.1.1 है, यहाँ पे 20.1.1. इन दोनों के बीच में भी नेबरशिप फॉर्म कर दूंगा BGP का.
correct logically वो भी
Right? But guys, if I am going to run two BGP neighborship between router 1, router 2, definitely it is going to use more CPU, right? If I have multiple customers here, then there will be issue. So we want to clear all the customer prefixes, all the VRF prefixes through BGP, right? And to differentiate the route, here we are using RD value. Right? Through RD value, my BGP will understand. the subnet. BGP is going to make it unique IPv4 prefix. That is called VPN v4 prefix. Right? VPN v4 prefix. What is VPN v4 prefix? VPN v4 prefix means IPv4 prefix plus RD value. This is called VPN v4 prefix. And MP-BGP is used to advertise VPN v4 prefix only, right? Till now you know the normal BGP. Normal BGP can advertise IPv4 prefix, and MP-BGP can advertise VPN v4 prefix, right? And VPN v4 prefix means IPv4 prefix plus ID value, not distinct.
So, sir, I have a question. So, RT travels from PE1 to PE2, right? With the
Yes, RT
prefix.
will travel
This
in the
VPN.
BGP. Yes, even RT value will also travel.
Okay.
RD,
Huh.
what is VPN? VPN v4 prefix will travel between P1 to P2, and VPN v4 prefix is combination of
Uh,
both.
IPv4 RD, correct. And RT.
And RT, what can be the definition of RT? Route target. You know, one RT is one busy community. Later you will learn busy community also. There are so many community, and RT is one of them. It is used to control the VRF prefixes, to import or export prefixes between VRF, and it is used for VPN v4. See the difference between MP-BGP and normal BGP. Guys, normal BGP, we can run normal BGP to advertise IPv4 prefixes,
IPv4 network, correct.
IPv6 subnet, right? Means we can say normal BGP support IPv4, IPv6
6.
only. Your MP-BGP support
VPN v4
MP-BGP,
prefixes.
VPNs prefix, VPNs IPv4 and IPv6. Also multicasting. Can advertise multicast fix well. And for the implementation, here you can configure it. Right, see two customers are there, IBM and Dell. This is IBM side 1, Dell side 1, IBM side, Dell side 2. Both customers are using same IPv4 prefix. Both the customers same IPv4. My point. So here let me check the configuration. So IP route OSPF. So I am receiving 3.3.3, ping 3.3.3.3, source 1.1.1.1 is also working. So IP VRF is not there, right? So IP interface brief, IP on serial 2/0 is configured, loopback is there, okay. And we have not configured the customer facing interfaces, right? So let's do it. IP VRF IBM RD value. Here I am going to use, let's say, 1:1 for customer A or IBM customer, and route target value I am going to use 100 ratio 100. Again, see here I have two options. Either I can export, I can configure RT export RT value, or I can configure import, or I can configure both. So what I am saying, for import as well as export, use 100 ratio 100. Same RT value 100 ratio 100. Right now, IP VRF L, and here I am going to define RT value 2 ratio for an example, and RT value I am going to define here. Now target both 200 ratio. Okay, 2 so IP VRF. Here you can see the VRF, right? But I have not added any interface till now. Let me add interface F0/0 IP VRF forwarding IBM, then IP address. IP address over here is going to be 14.1.1.1 255.255.255.0.
0.
Then finally no. Exit interface F1/0 set IP VRF forwarding tail, and route target value IP address
IP address
15.1.1.1 255.255.
0.
So IP route VRF tail done. So IP route VRF done. Now see, in both the VRF, R1 is going to receive same subnet, right? 10.1.1.0 to 10.1.3.0. And guys, here between 1.1.1 and 3.3.3 we are going to run BGP, right? And now my BGP can differentiate the prefixes, right? Because R1 is not going to make VPN v4 prefix. Whatever prefixes router 1 will receive on this interface, which is the part of VRF A, it will add RD value 1 ratio 1. Right? Here I can write the RD value and RT value. RD value IBM and L. For IBM, my RD is
1:1.
1 ratio 1, and my RT 100 ratio,
100. 100.
and for Dell, RD is ratio 2, I think.
Yes, sir.
Target value is so. अच्छे से समझ में आ गया ना, तो ये बहुत आसान टॉपिक है, समझ देन कॉम्प्लिकेटेड हो सकता है. Now between router 1 and router 4 I can run any protocol. Let me configure EIGRP for customer A and OSPF for customer B. Means for IBM I am going to configure EIGRP. Let me check here on router number 4. I think protocol is running. Protocol is already running. So IP protocol summary. Protocol is not. So IP interface. IP is already configured. Let me do one thing. Router EIGRP as number 10 and network 0.0.0. On router number 5 also. Config router OSPF 1, the network 0.0.0, 0.0, 5 to 5, 5. Yeah. Then go to router number 1, config router EIGRP as number 10, and then address family IPv4 unicast VRF IBM and autonomous system number 10 and network 14.1.1. auto. Here we have neighborship. Similarly, I need to configure OSPF also. Router OSPF 1 for VRF. Del.
यहाँ पे सर VRF ही नहीं बना हुआ, आई थिंक डेल
तो
है तो सही, और इंटरफेस का साइन भी है। सर वो बाय डिफॉल्ट आई थिंक उसमें चले जाता है ना। उस पे अपन ऑलरेडी है सर इस पे।
अच्छा, एक OSPF तो हमने इसके लिए चला रखा था 1.1 एंड 1.3 के पर इस बैक
SE लिख दीजिए सर।
IP 1
0 इंटरफेस
तो
सर पॉइंट टू पॉइंट ही होगा इसमें।
IP run type is broadcast alt 1 this loop back 1 IP F 0 IP router OSPF number 10. I'm running OSPF process 10 over here for VRF.
डेल
मैं एरर भी गलत दे रहा था ना, बोल रहा था VRF ही नहीं मैच
हाँ डेल के ऊपर दे रहा, हाँ डेल के ऊपर एरर दे रहा था सर वो।
work dot 1.1.0 .0.255 so IP route VRF
डेल
IBM all these are coming VRF Dell
ये यार इंटरफेस सेट हो गया।
dot 1.
टेस्ट है।
So IP interface brief interface F0/0 yeah this is in IP should be
14 dot
15
yes 15.5
interface F0/0
15.5
this dot 1 dot 5 tab perceive working so IP F per tell VRF now and you can see the are available just 1 minute. Now we need to perform similar configuration on site 2 and P2 router R3. So let me access R6, R7 on R6. So IP interface brief config, or let me
सर हम सेम उस पे प्रोसेस क्यों नहीं यूज कर पाए थे उसमें? बिकॉज वो तो कोई मैटर नहीं करता व्हाट वी आर डिस्कसिंग ओएसपीएफ।
नहीं करता है। एक OSPF आपने IPv4 के लिए ऑलरेडी चला के रखा हुआ है। वही तो ये बोल रहा था कि OSPF A, OSPF प्रोसेस ID 1 ऑलरेडी रन हो रहा है और वहां पे VRF मैच नहीं कर रहा है, डेल VRF।
ओके
But address dot 1.1.5 dot 5 to two dot 1.1 back 3 dot 1 dot after that router AGRP CAN and network dot done. For R7 here IP will 37.1.1.7 1.1.7 up to backs are same RP here F router
प्रोसेस
F1
प्रोसेस 10
and 1 is already running work dot 0 55255 yeah
0
for the OSPF on loopback interface you can change network type IP OSPF, otherwise on
नेटवर्क
loopback,
पॉइंट टू पॉइंट
otherwise on the loopback
डीआरबी
interface
डीआरबी नेटवर्क पॉइंट हाइफन
class 32 से फिर copy done. Done. Here I am going to save the configuration of R6. The R6 router
ओएसपीएफ 10
F 10 और 1
10th
यहाँ पे हम 1 भी कॉन्फ़िगर कर सकते हैं. Process ID can be different as well. That is not the OSPF universal parameter. And on R5 the network type on back interface range back 1 the IP OSPF network. Now on router number 3 the VRF IP VRF
सर 6 पे हमने आईपी एड्रेस वगैरह उड़ गई है अपनी
IP address interface F0 address 30 dot 5525.
Mm-hmm.
VRF RD value here, one same RD value I am using, and dot target value for both. If you can export 100 video,
100. Okay. 100.
VRF tail RD value here, and route target value I am using. If you will not define both, it will consider. Then interface F /0 IP VRF forwarding IBM search IP address 36.1.1.3 dot interface F/0 IP VRF forwarding
Dell.
L search and IP address 1.1.1.3
Mask.
router KGRPS number 10 address IPv4 cast VRF IBM and autonomous CAN and network 30.1.1.0 auto summary. Router OSPF 10 VRF tail and network 37.1.1.0 wildcard mask 0.0255 area.
0.
So IP route VRF tail VRF IBM. Okay, all 20 subnets are there,
Mm-hmm.
and in the Dell again all 20 subnets are there, right? So on P1 router, like on router number 1 we have 10.1.1.0 to 10.1.3.0 in both the VRF, as well as on router number 3 also we have 20.1.1.0 to 20.1.3.0 both the VRF. Now we need to exchange these prefixes between R1 and R3. Clear? Now we need to exchange these prefixes between R1 and R3, between P1 to P2. OSPF में एडवर्टाइज कर दूं तो OSPF चल रहा है, क्या इशू होगा?
सर उन दोनों के बीच S2/0 में भी सर
सबसे पहली बात तो हम
अच्छा।
कर ही नहीं सकते हैं ना,
कर ही नहीं सकते सर, बिकॉज डायरेक्टली सेम सबनेट होना चाहिए उस पे में।
कर देंगे तो क्या होगा, पी राउटर के पास भी सारे कस्टमर के प्रीफिक्सेस आ जाएंगे राउटर 2 के पास, राइट? एंड लाइक राउटर नंबर 2 आई विल हैव लॉट्स ऑफ राउटर्स गाइस बिटवीन P2 P। अगर मैं सर्विस प्रोवाइडर की नेटवर्क आपको दिखाऊं ना, सर्विस प्रोवाइडर वर्क, ये तो हमारे जैसे दूसरे अपने लैब के लिए ही डिजाइन किए वही सब है, राइट? बट अगर आप रियल सर्विस प्रोवाइडर का नेटवर्क देखोगे देन यू विल हैव लॉट्स ऑफ प्रीफिक्स, लॉट्स ऑफ राउटर्स। These are the routers. Point दिख रहे हैं? ये point. These are routers. Internet is what? Multiple service provider is only internet, right?
करेक्ट।
So this can be the service provider network. This router can be P1. This router can be P2. So between P1 to P2, you can see so many paths are there, right? So many paths are here. So I will not inject customer prefixes in the routing table of provider routers. That's why we have BGP. So let's do one thing now. Let's configure first BGP neighborship between 1.1.1 and 3.3.3. Let me take you to R1 config tree and router BGP AS number, for an example 100, and then address family, and address family I'm not going to configure address family for IPv4, not for IPv, not for L2VPN, not for VPN v6, but for VPN v4. So let me say VPN v4, address family VPN v4, and here I will define the neighbor. Who is neighbor? 3.3.3. Guys, before this, how to enable BGP on router number 1? Router BGP 100, the normal
The neighbor
BGP.
command.
Neighbor
Yes.
3.3.3.3, remote AS
100.
100,
Suppose.
and after that you can update the next
Network
hop.
command.
Sorry, loop back, update,
Yes, sir. Update source loopback. Neighbor 3.3.3. Update source loopback.
update source loop back 1. This is how we can
Yeah.
configure BGP. On router number 3 also I am going to enable BGP. Config T, router BGP as number 100 and neighbor 1.1.1.1, and remote AS of this neighbor is again 100 and neighbor 1.1.1.1, update source back.
Well,
Now you can see we have BGP neighborship here, correct?
correct, sir.
So IP BGP summary. So this is IPv4 BGP neighbor. Which neighbor it is? IPv4
IP.
BGP neighbor. It can carry IPv4 prefixes, not VPN v4 prefixes. So IP BGP summary, right? And here you need to add one extra command. If you want to enable BGP for VPN v4 between 1.1.1 and 3.3.3, then you have to use address family. Router BGP is number 100 and address family VPN v4. And here I am going to say neighbor 3.3.3.3 activate. This is the extra command which I am adding here. I am activating this neighbor for VPN v4. I am activating this neighbor for VPN v4 prefix. On router number 3 also, go to R3, config T, router BGP is number 100, address family VPN v4, and neighbor 1.1.1.1 activate. Right now we have IPv4 BGP neighborship as well between 1.1.1 and 3.3.3, as well as VPN v4 neighbor as well. So IP BGP summary. So through this command, what you can verify? IPv4.
So IPBGP all summary, sir.
So
If you can
IP
run.
BGP all
Hmm.
all summary.
Both fields. Yes, sir. Both it will show.
No? Showing
Sir, VPN v4 unicast edition. No?
where?
So for address family VPN v4 BGP router identifier this it is showing. So दो बार आ रहा है ना?
हाँ ये नीचे
हाँ हाँ ऑल में आ जाता है सर सारे.
all में आ जाएगा और एक और कमांड होना चाहिए. तो IP ये
So
GR
IPv
sorry
so IPBGP VPN v4
VPN v4
नहीं
summary.
question mark all. Right.
ये तो BGP टेबल दिखा रहा है ना.
Okay. हाँ correct.
In the BGP table I don't have any subnet. Can anyone tell me why? The BGP
So
table,
network command.
yes, network command or redistribute. Either I can use network command or I can redistribute EIGRP into BGP as well as OSPF into
BGP.
right. So IP VRF verification command here. Option.
Sir, एक command हो रहा है show IP VRF interfaces, so it will show the interfaces and the
Here we can verify the RD, RT, those value for the VRF.
show IP
Interfaces
VRF.
are also there. VRF
Correct.
Dell, the interface, RT value import and export. This is export and this one is import. For both I am using same. And here is your RD value.
सर इंपोर्ट के लिए अलग से वी कैन डिफाइन एंड एक्सपोर्ट के लिए अलग से भी वी कैन डिफाइन,
हाँ, yes, yes.
अच्छा,
I can import 100 ratio 100. I can export 500 ratio 500.
ओके।
VRF L. So these are the verification commands you can use. Fine. Now let me do one thing. Let me redistribute EIGRP into BGP here. Right now we have VPN v4 BGP neighborship between 1.1.1 and 3.3.3. So whatever prefixes we will install in the BGP table on router number 1, router 1 will advertise it to router 3 also. Correct, guys?
करेक्ट सर।
हाँ, नेबर के साथ तो एडवर्टाइज करता ही है ना सारा प्रीफिक्स,
बिल्कुल।
राइट? तो लेट मी से राउटर BGP केस नंबर 100 and its family VPN v4 or for VRF. This is also option, right? Here we can call VRF as well. Here I can call VRF IBM, and here I can run redistribute command. Redistribute EIGRP ES number was what, guys? What was the ES number of EIGRP? 100 or 10?
10 था सर।
10 था।
R4 पे वी कैन चेक।
So IP protocol EIGRP
10।
enter over here, and now if you will check BGP table, so IP VPN v4 and all. Now you can see all the subnets 10.1.1.0 to 10.1.3.0, and this is the subnet which is running on the WAN link. Right now, if you will open this any prefix, let me open anyone. So IP BGP can be for all and 10.1.1.0 for an example. So IP all 190 10.1.1.525 to 5.0.
क्या देखना है सर?
Till then, first let me do one thing. Let me advertise the Dell prefixes also here. Router case number 100 and its family IPv4 cast VRF Dell and redistribute OSPF. Process ID was 10 here, and so IPv4 all. Now here you can see, guys, here is the role of RD value. Right, see in the BGP table on router number 1 I am able to differentiate the prefixes. Right, how BGP knows that these prefixes belongs to VRF IBM and these prefixes belongs to VRF Dell. because of RD. Getting my point? Because of RD value, BGP is able to differentiate it. What I told to VRF IBM that export 100 ratio 100. So now BGP is going to use that RT value to export, to advertise these prefixes to their neighbor. Community is also, guys, one kind of tag, right? So whatever community we have in BGP, it means what? It means whenever router is going to advertise prefixes to their neighbor, it will add those community. Like, you know, for eBGP neighbor, router always add AS number, AS path, yes or no? In the similar way, we have community concept. So when router 1 is going to advertise prefixes to router number 2, it is going to add route target value, RT value, BGP community. And router 3 already know that if RT value is 100 ratio 100, then I will import it in this VRF. If RT value is 200 ratio 200, then I will import it in this VRF, this side. Right? So we can verify it on router number 3 now. Go to R3 and check BGP table. So IP, BGP, VPN V for all. You can see here also I am receiving all the subnets. Right? And route distinguisher is differentiating the VRF prefixes. Okay. On router number 1, so IP and V4 VRF IBM. Okay. Output VRF IBM till will the BGP table of till VRF. Here.
So show IP-BGP unicast something command is there, sir.
Here is your VPN V4. See how VPN V4 prefix look like. Guys, what I told you, it is combination of IPv4 prefix plus RD value, right? So this is VPN V4 prefix 4. Any other VRF? Here I am going to change the VRF till. Then it is going to be 2 ratio 2 10.1.1.0/24. Right? So whatever prefixes are going to be redistributed into BGP, into the BGP from VRF IBM. From VRF IBM. For those all prefixes, it is going to add RD value 1 ratio 1. Right? So my first subnet is going to be 10.1.1.0/24. Second subnet is going to 1 ratio 1, 10.1.2.0/24. And for del VRF, 2 ratio 2 and then 10.1.1.0/24. So now you tell me this one and this one, both are unique or same? Both are unique because of RD value. Right? Hope now you are able to understand it. Now, on router number 3, we have verified here also I have all the subnets VRF and V4 VRF till like this also you can check. Now let me check IBM. Now will R3 advertise this subnet to R6? Will it advertise? On router number 6, so IP route EIGRP. Guys, I'm not learning any prefix through EIGRP, right? Reason is redistribution.
Redistribution.
Right? Here we are running EIGRP and here we are running BGP. So it is learning R3 is learning prefixes through BGP. It will not advertise it to EIGRP protocol. So here now we can redistribute BGP into EIGRP. Right? Similar way here
But
on
sir,
router number,
please
yeah.
check it for VRF. Sir, please check it for VRF IBM. IP route EAGRP VR
Where?
Dell VRF
On router
IBM.
number 6.
Okay, R6. Okay, R6 पे it is not there. Yeah, okay, got it. VRF is not there. Yeah.
यहाँ पे आप routing table check कर सकते हो. So IP route VRF L. So we have all these subnets, right? 10 and 20. In IBM also, all the subnets are there, 10 and 20. These are coming through BGP protocol, and these prefixes are coming through EIGRP protocol. In the Dell VRF, these prefixes, all 10 prefixes are coming through BGP, and 20 are coming through OSPF. Now we need to redistribute BGP into EIGRP and OSPF. So go to R3, say router EIGRP as number 10. Address family, IPv4, unicast, VRF, IBM, and then redistribute protocol. Guys, whenever we are redistributing any protocol in EIGRP, what is the criteria? What is the process to
Sir, K
advertise or
values, K
redistribute?
values, K values.
A,
Sir, K values.
K values. First of all, BGPS number 100, and then metric components we need to define here, right? Metric, and then we can say K1 value, bandwidth, it's okay, port,
Reliability. MTU 1500. Sir.
and now I am expecting side 1 prefixes of IBM in side 2. Right now on R6 we can check routing table, and you can see all the subnets are coming, right? All
Correct,
the
sir.
subnets are coming. So how router 3 have exported to router number 6 to VRF IBM? Everything is there in prefix. So IP, BGP, NV4, VRF, IBM. Okay. Route distinguisher, we have here configure it, right? So whenever router 3 will import any prefix in VRF IBM, it will add here again route distinguisher value. And if I will open it in detail, like so IP, BGP, VPN, V4, VRF, IBM, and 10.1.1.0. So here you can see your VPN, V4 prefix. Right now router 3 know, okay, here RT value is 1:1. That means this prefix belongs to which VRF? VRF
Dell.
IBM.
Oh, sorry, IBM.
IBM VRF na?
Mm-hmm.
Yes or no, guys? Yes. And what is RT value, route target value? You are importing here. What RT value is coming in the update message? 100:100. And so IP VRF, you have already told to this router that IP VRF tail. You have already told to this router that whenever RT value is 100:100, just import it to which VRF? Import it to VRF IBM. This is how R3 will advertise these all subnet to router number 6. Right? So the function of RD and RT is different, right? Both are not same, and we can note use only RT or RT, right? We have to use both the value. One to import and export the prefixes in correct VRF, and one to differentiate the prefixes, right? Similar way on router number 3 we can redistribute BGP into OSPF also, router OSPF, then VRF L, and here we can say redistribute BGP as number 10. What is the criteria of redistribution prefixes in OSPF? Subnet keyword, and then
Correct,
you
sir.
can manipulate the cost, you can use route map, those things I am not using over here, right? You can define the metric, leave everything on default, and go to router number 7 and check the routing table. So IP route OSPF, you can see you are learning all the prefix, and these are guys 10.1.1.0/24 is which type of prefix it is? Intra area prefix,
IPv4. Correct, sir.
Inter area.
right? But what till now what we learned, that redistributed prefixes comes in the OSPF domain in form of LSA5 external. It should be E1 or E2.
Correct, sir.
मतलब OSPF भी भूल.
हाँ सर, डिस्ट्रीब्यूट कर रहे थे जब हम लोग, तो उसमें E1 या E2 के फॉर्म में आ रहा था सर.
Now guys, here on R3, what I am going to do, I am going to advertise 20 subnet. I am going to redistribute again EIGRP into BGP and OSPF into BGP, so that R3 will also start advertising 20 subnet to router number 1, right? Till now in the BGP table, so IP, BGP, VPN v4, VRF, L. So here you can see we have only 10 subnet in the BGP table. 20 is not there because of redistribute, right? So let's redistribute router BGP is number 100, address family IPv4, unicast, VRF, IBM, and redistribute EIGRP as number
Post. Yeah.
10.
Yeah.
The similar way here, address family IPv4, VRF, Dell, and redistribute OSPF ID 10, right? And so IP BGP, VPN v4, VRF, Dell. Now 10 and 20 both subnets are there, right? In VRF IBM, both the subnets are there, 10 and 20. Let me take you to router number 1. So IP BGP, VPN v4, VRF, 10, 20. 20 prefixes are coming from 3.3.3, right? In IBM also, all the prefixes are there. So here now we need to redistribute BGP into again EIGRP and OSPF, so that it will advertise to customer as router, right? Configure terminal mode and say router EIGRP as number 10, address family IPv4, unicast, VRF, IBM, and redistribute BGP as number 100 and metric it address family router OSPF 10 VRF Dell, and distribute yes number 100 and put subnet. Now go to router number 4 and show IP dot EIGRP. Will troubleshoot it. Take R5 IP route OSPF. Okay, here 20 subnets are right. So now IBM can communicate with side 2, side 1 and side 2 of IBM can communicate ping 20.1.1.1 and source 10.1.1.1. Okay, ping will not work because we have not enabled MPLS. So router 2 P router don't have route, right? So ping will not work until analysis we will not configure the MPLS over here. And our next topic is going to be MPLS only, guys. Don't worry. So IP route EIGRP here. Why I am not this? R1. So run section router AGRP. AGRP case number rate IP 4 AGRPS number rate.
It was 10 basically, sir.
10 is there.
Okay. Okay. Now after enabling MPLS side scan, clear MP-BGP, VRF, RD, RT, and implementation.
Clear, sir.
So now let's start MPLS. How router 2 is going to forward traffic without having route?
Sir, sorry, before starting into MPLS, I think we talked about a scenario like VRF on multi-layer switch, and this scenario said that we'll discuss this scenario.
In multi-layer switch also it is going to be work like this only. We have same concept. The multi-layer switch, what will happen? What is the difference on multi-layer switch? Multi-layer switch means what, guys? Router and switch. Multi-layer switch means router plus, right? So multi-layer switch is going to work like a router only. Here we can configure IP address 12.1. Here I can configure IP 12.2. Here I can have loopback 1.1.1. Here I can have loopback 2.2.2, and between 1.1.1 and 2.2. Can have neighborship MP-BGP. Don't need to learn the same concept on multi-layer switch. It is going to be exactly same. Doesn't matter, guys, this is router, this is multi-layer switch, or this is firewall or any other devices, right? We can have any devices here which supports routing. That's it. So brother, we don't need to perform same lab on multi-layer switch. You can try it by yourself. It will work exactly same. design another types of network as well, like in the service provider network.
Sir, can we implement this lab on layer 3 switches?
Layer 3 switch is the only multi-layer switch, na brother?
Yes.
Yes.
Okay, so behalf of VLAN, we can implement on all commanded या other way.
VLAN से भी कर सकते हो आप, मल्टी लेयर स्विच पे डायरेक्ट आईपी एड्रेस भी तो कॉन्फ़िगर कर सकते हैं ना हम इंटरफेस पे।
Okay, I will try to do that, but
आईपी राउटिंग इनेबल करके।
अरे इस इंटरफेस को हम लेयर 3 इंटरफेस नहीं बना सकते हैं क्या?
but I
Yes,
didn't,
sir.
I didn't do that, na. That's why I am clear about from your side. Okay, actually this lab is already a perform.
To it here you can configure the IP address on multi-layer switch as well.
Okay, okay.
So in your case, guys, you can design this type of topology. These are the P router and some routers are there. Right, and you can connect so many customers. To the actual service provider network. Here you can have one customer. Here you can have one customer, right? Or same customer can have 4 sites. Right? You can try to configure route leaking as well. Route leaking means, let's suppose here now there is requirement. Requirement is in IBM, guys, we have one more subnet, or let's say this is the subnet only. Now the requirement is the IBM server should be reachable from Dell side 2. Dell side 2. So what I can do here on R3, I can configure what? RT value export 100:100 in Dell VRF. It will start advertising IBM side 1 prefixes to Dell side 2. You don't need to learn
Do
it
it.
if you are not able to understand it. Here we are using same subnet. For an example, you can see subnet between router 1 and router 4 is 14. 14 subnet is there in the routing table of R6, 14.1.1.0. On R7, we will not find 14 subnet here, right? But on router number 3, on R3, I'm going to say config T and IP VRF Dell and route target import 100 ratio, and after running this command, if you are going to check R7 routing table, you'll have 14 subnet also.
Clear IP route.
Here IP out. IP VPN v4 VRF here na 14.1.1.0/20 in the Dell VRF. Right, so it is now 14.1.1.0/24 is coming. So
अभी
this way
कैसे आया सर ये?
कैसे आया, मतलब हमने बताया ना राउटर 3 को भाई, जिस भी
नहीं
प्रीफिक्स
पता।
में आरटी वैल्यू 100 है और 100 है उसको इस साइड में इंपोर्ट कर दो, उसको डेल वीआरएफ में इंपोर्ट कर दो।
Okay.
सर 36 भी आ गया इसके साथ में?
हाँ 36 सारे प्रीफिक्स जो VRF जो भी राउटर एक्सपोर्ट कर रहा है 100 रेशियो 100 वो सारे प्रीफिक्स अब इसमें इंपोर्ट हो जाएगा. दैट इज द मीनिंग. Whatever prefix is exporting RT value 100 ratio 100 that will be imported in this VRF. Just forget it. You need to configure the basic VRF only, right? MP-BGP RT RD RT, and even in one side is also sufficient. If you are going to between same customer, two sides are there of a single customer, that is also sufficient for.
Sir, can you confirm the connectivity check between them?
Connectivity check between Dell and IBM.
Yeah. For this one, PE2 side one.
PE to side 1.
Yeah.
Side 1 to side 2.
No. On the side 2, you just configure this one. This one. Just
From where to where you want to check connectivity? Here to here.
Sir,
on
yes, sir.
side 2.
Cross VPN route link.
No. This one on side 2, Dell to IBM.
Side 2, Dell to
IBM.
IBM. Between here.
Yeah.
So IP route OSPF ping 36.1.1. Will ping work, guys? If ping is not working, then tell me the answer. What will be the source
Sir, it
IP
will not
address?
work.
37.7. R6 के पास क्या route है?
No, sir.
R6 does not have route, right? We have only import Dell prefixes in, sorry, IBM prefixes in Dell, right? We have to here route link between Dell to IBM means
IBM.
हाँ दोनों का prefixes दोनों में import export. If route is there, then ping will work on.
Okay, sir.
तो आपका चांस है अब कॉन्फ़िगर करना, DB टोपोलॉजी बना. Now, I am interested to discuss now MPLS.
Can we start it from tomorrow, sir? Because बहुत config हो
अभी
गया.
तो टाइम है ना अपने पास एक
घंटा.
सर 15 मिनट है सर.
सर 15 मिनट.
मेरे मोबाइल गलत है.
सर डेस्कटॉप पे देखिए आपके.
MPLS करेंगे, but let me give you the basic idea about the MPLS. Like if I have three daughter R1 R2.
सर सॉरी टू डिस्टर्ब यू, मेरे को ये जानना था कि अभी बीजीपी पूरा कंप्लीट हो गया, करेक्ट? ओके, अभी नया टॉपिक स्टार्ट हो रहा है IMPLS.
BGP कंप्लीट हो गया, उसके बाद VRF कंप्लीट हो गया, फिर उसके बाद MP-BGP कंप्लीट हो गया, अब स्टार्ट हो रहा है MPLS.
ओके, थैंक यू.
So for an example, I have three daughters. MPLS, guys, what we are going to do? Till now, what you know, how routers forward the traffic? You know, router forward traffic by checking routing table, right? According to you, router forward traffic by checking routing table. But that is not true. And this is very old method of traffic forwarding by router. By checking routing table. If router is checking the routing table, that means router is directly using CPU. Right? Router is checking if guys, let's say router 1 is receiving a traffic where destination IP address is 10.1.1.1, 10.1.1.1, right? So to forward this traffic, router is going to check routing table. In the routing table, it is going to check 32 bits information. Length of IP address destination IP is 32 bits. It is going to run command so IP route and 10.1.1.1. If route is there, then only it will forward, otherwise it will discard. So router is going to check 32 bits address. But if I have lots of router, let's say 1000 number of routers are there between source and destination. Let's say you are accessing the Google server, and between your PC and Google server there are 1000 routers. So if all the 1000 routers are going to check their routing table 32 bits address to forward it, then guys there will be delay, right? There will be delay, right? Processing delay at each router. Each router can take around 1 to 2 seconds to process it. If one router is going to take 1 second, let's say, to take forwarding decision, it will receive the traffic, it will decapsulate at layer 2, it will remove with the net header, it will check destination IP, it will compare destination IP with routing table, and then it is going to add layer 2 header and then forward it from the interface. This is the process, right? This is the only process. So with the help of this process, if one router is taking 1 second, if one router is taking 1 second and 1000 routers are there between source and destination, what will be delay? 1000 second. 1000 second. For an example, in this scenario only, right? In side 1 or in side 2, let's say in the side 2 of Dell, there is one server, right? And there is some requirement of this server. The requirement of this server is, the requirement of this server is, this server can work smoothly if the delay is less than or equal to 30 milliseconds. Right? That is the requirement of this application. I am running one application over here, and this is the requirement of that application, right? 30 milliseconds should be the delay, not more than that. What do you mean by 30 millisecond delay? Guys, this is the total delay. Let's say here is one user, and this user is going to use this application, right? So total delay of request going from PC to server and reply coming from server to PC should be equal to and less than 30 milliseconds. Then only this application will work properly. Otherwise, you are going to complain that, hey, I am not able to the application. And in the service provider router, there are so many routers. Then there will be issue, right? There will be issue. Guys, what is the meaning of monitoring, network monitoring? Why companies are hiring so many network engineers? Generally, if I will talk about the very common scenario, right? So generally in the network, just give me 5 minutes. I am going to give you one typical enterprise network design. In the enterprise network, we will have data center. We will have data center, and in the data center, I will have lots of resources. Right? Some servers are and some branches are there, branch 1, branch 2, branch 3, branch 4, right? And all these branches and data center are connected through any transport. It can be internet, it can be MPLS. In 95% cases, more than 99.9% cases, you will be using multiple transport, internet and MPLS, right? Can anyone tell me why internet and MPLS? Because MPLS is, guys, costly. MPLS is costly. If I am going to forward all types of traffic through MPLS only, then it is going to cost me so much money, right? If my requirement is, let's say, 1 Gbps or 500 Mbps, so 500 Mbps bandwidth over MPLS is going to be very costly, 10 times more cost than internet. So if I need 500 Mbps bandwidth between data center and all the sites, right? And I have some critical servers. They need 100 Mbps reliable link, right? So I am going to purchase 100 Mbps link from MPLS, and for rest general traffics, 400 Mbps is required for general traffic like accessing internet, and users want to access internet, to access general application, right? To communicate with each other, to exchange files between the branches or data center, right? So that's why we will have generally two transport, internet and this is for load balancing also, this is for redundancy also. By the way, MPLS will not goes down like this, because when we'll purchase connectivity from MPLS service provider is going to sign the agreement, that is SLA, service level agreement, right? Like he is going to promise you that, let's say 5 hours of downtime per year, right? Even though this is used, 5 hours per year downtime is used, but internet is even not reliable, right? No one is there who can sign the SLA, who can give you the agreement, but it is 10 times 20 times cheaper than MPLS. So for all the general traffic I am going to use internet over here, internet, right? Sometime maybe this link is behaving better than MPLS, sometime MPLS is, in most of the time MPLS is behaving better. So what I tell you here, I have one application and requirement of that application is 30 millisecond delay, right? So for this application, which transport I will use? Definitely MPLS, definitely MPLS, because MPLS is more reliable than
UDP.
more reliable than internet. For an example, what customers are complaining here, customers are complaining that in a month or in each week, for few times my end users are not able to access the application, right? Per week, for few times, for let's say 10 minutes in a week or in a month, users are not able to access the application properly. That means, guys, sometime the quality of this link is going below, right? And let's suppose here the delay on this MPLS link for a particular time is 100 millisecond, and at that time delay over here is 25 millisecond. So for a particular time when MPLS is behaving like, or we can say the quality of MPLS link is bad, at that time we can shift this application traffic over internet. But how I will get to know that now internet is behaving better than MPLS? That's why I need engineer who will be keep monitoring my WAN link, who will be keep monitoring the WAN link. Every day in the company we are monitoring the network, we are checking the performance, health of devices, CPU utilization, WAN link, is there any error? This is the reason why companies are paying to the engineers, right? And they have hired so many engineers. You are not going to design the network. Right?
Sir, I have one question. How do they actually monitor the delay apart from tools?
That is not our concern. Leave it.
But generally बस पूछना चाह रही थी कि नेटवर्क में
आप
कैसे
ये सोचो कि
usually
यहाँ पे स्काई में एक आदमी बैठा हुआ है, वो देख रहा है दोनों लिंक को, है ना? जैसे गूगल मैप है। अब मैं आपको
हाँ
बोलूं,
मतलब I just wanted to know the tools they use for monitoring the delay actually
आप
real time में
SNMP का नाम सुने हो?
हाँ SNMP आइडिया है SNMP I know
SNMP भी एक नेटवर्क मॉनिटरिंग टूल है। ऐसे ही बहुत सारे मॉनिटरिंग टूल है। जैसे ये आपका हाउस है, घर, और ये मार्केट है। आपके घर से मार्केट जाने के 3 रास्ते हैं। रोड है, आप म्यूट करो, पहले तो पिक आ रहा है, राइट? अगर आप अपने घर से बैठे हुए चेक करना चाहते हो कि किस रोड पे ट्रैफिक कम है ताकि मैं जल्दी मार्केट पहुंच सकूं, तो आप क्या करोगे? गूगल मैप ओपन करोगे और गूगल मैप आपको बता देगा। तो कैसे बताएगा गूगल मैप? भाई स्काई में क्या है? सैटेलाइट है जो कि सब कुछ देख रहा है, जिसको सारी कुछ दिखाई दे रही है रोड पे। भाई कौन सा रोड खाली है, कौन से रोड पे कंजेशन है, कहाँ से जल्दी पहुंचेगा। तो उसी तरीके से हमारे पास बहुत सारे टूल्स होते हैं जिससे हम लोग नेटवर्क को हमेशा मॉनिटर करते रहते हैं, राइट। तो एक तो चैलेंजेस अपने पास क्या है यहाँ पे कि बिटवीन सोर्स एंड डेस्टिनेशन इफ देयर आर लॉट्स ऑफ डिवाइसेस then we'll get high delay, more delay. And guys, if I will talk about the voice traffic, for an example, voice traffic, you know about voice traffic? If someone is here talking to someone on the call who is sitting over here, right, and voice is a very delay sensitive. Delay sensitive means delay should be minimum for voice traffic. अगर हम दोनों बात कर रहे हैं कॉल पे और कुछ वॉइस ही ब्रेक हो रही हो, हर सेकंड पे कुछ आवाज ब्रेक हो जा रही हो, तो कितनी इरिटेटेड होंगी, क्या हम बात कर पाएंगे? Right? And if router is going to check, all the routers is going to check their routing table, it will perform 32 bits check every time for each and every packet, then definitely latency will be very high here. Right? So that's why we come up with another method of traffic forwarding on router. Checking routing table to forward traffic is very old method. Nowadays in service provider, when we have lots of routers between source and destination, that time router is going to check one very small label to forward traffic. Label to forward traffic. Even this label is not the part of CPU. By checking their data plane, router can take forwarding decision, and here MPLS comes in picture. जब हम लोग वो एप्लीकेशन 30 मिलीसेकंड वाले एप्लीकेशन को एक्सेस नहीं कर पा रहे थे ना, देन हमारे पास रिक्वायरमेंट आई कि यार ये तो राउटर बहुत टाइम ले रहा है पैकेट को फॉरवर्ड करने में, प्रोसेस करने में, प्रोसेसिंग डिले इज यूज, हाउ वी कैन रिड्यूस दिस time processing delay over here on the routers, right? So first we come up with SAF. See, there are some multiple types of forwarding, right? First one is packet processing, which is the oldest method, and packet processing is the only method where router is going to check routing table to forward traffic. Packet processing, right? Packet processing means router is checking their routing table 32 bits address to forward traffic. If it is IPv6 address, then even it is going to check lengthy information. Then we come up with SAF, which is by default even enable your on your router by default right now, guys. If I am going to ping from side 1 to side 2, if MPLS is not enabled, then also router is not going to check their routing table. It is going to check SAF table. It is going to check SAF table. Here we can check, show you on router number 3, show IP SAF. So see, this is nothing but the duplicate copy of routing table. Duplicate copy of routing table, and router will check this SAF table to forward the traffic. Even SAF is sufficient for enterprises. If you have few routers between source and destination, but if I have 100 number of routers, 1000 number of routers, then SAF is also not sufficient. That's why we come up with MPLS. And in MPLS, what you need to learn, how router is going to forward traffic by checking table. You know how router forward traffic by checking routing table. In similar way, you have to learn how router is going to build a label table, how router is going to add the label, and how router will use that label to forward the traffic, right? So also we'll understand the MPLS. After that, here you can enable MPLS between router 1, 2 and 3, and these sites will start communicating with each other. If you will check the routing table of router 2, you will not find any customer. एंड ये सब जो डिज़ाइन है ना इंटरप्राइज के, ये सब बहुत बहुत बेहतरीन सिनारियो है कॉन्फ़िगर करने के लिए. मेरे चैनल पे तो बहुत सारे वीडियो ऑलरेडी अवेलेबल है. ऐसे सिनेरियो सबकी कॉन्फ़िगरेशन की, किस तरीके से हम ट्रैफिक को क्रिटिकल बिजनेस मिस क्रिटिकल ट्रैफिक को MPLS लिंक पे भेजे, कहाँ से इंटरनेट पे, राइट। और बाद में तो और प्रॉब्लम आया जब हम इसको सर्वर को कहाँ पे डाल दिए, यहाँ से उठा के। आजकल की टाइप की बात करूँ ना, आज की नेटवर्क, टूडेज नेटवर्क, तो गाइज इवन वी आर नॉट होस्टिंग दिस एप्लीकेशन इन डेटा सेंटर, नाउ we have put it this
Cloud.
application over here on the cloud,
Cloud.
right? So अब तो और डिले होगा, पहले डिले 25 मिली सेकेंड था, तो अब तो डिले होने वाला है 100 मिली सेकेंड। पहले अब ब्रांच यूजर जाएगा डेटा सेंटर, फिर डेटा सेंटर से जाएगा इंटरनेट पे, फिर इंटरनेट से कनेक्टेड है क्लाउड, फिर जाएगा क्लाउड पे, फिर वैसे ही रिप्लाई आएगा, right? So that's why we come up with what? Another technology, SD-WAN, right? So here is the SD-WAN who is going to solve your issue. तो जितने भी टेक्नोलॉजी है ना, MPLS हो या MP-BGP हो, कोई ना कोई इशू को सॉल्व करता है, राइट? एवरी टेक्नोलॉजी इज सॉल्विंग द मेजर इशू, लाइक गाइस MP-BGP is solving what? MP-BGP is solving the issue which earlier we were not able to advertise multiple VRF prefixes through single neighbor, through single routing domain, through single path, right? So this is the reason it is solving the major issue. This is the reason why we are using it in the industry. जब आप इसको कॉन्फ़िगर करोगे ना इस सिनेरियो को, then you will get to know that branch user cannot directly access the cloud application, right? Because your security appliance is there in the data center. So first we will forward all the traffic to data center. In the data center, I have configured the security policy where we will inspect the traffic, and then we will decide whether it should go to cloud or not. It is allowed to access the application or again latency is very high, and nowadays we are implementing the SD-WAN to solve. तो सारे टेक्नोलॉजी आपस में कनेक्टेड है, हम लोग राउटिंग स्विचिंग एकदम जीरो से क्यों पढ़ रहे हैं, राइट? सो दैट वी कैन अंडरस्टैंड फर्स्ट द इशू and then which protocol, which technology is solving that is. If I will talk about the NAT is also solving major issue. VPN is also solving major issue. BGP, if we have so many IGP protocol like OSPF, PIG, RP, why we come up with BGP? BGP is solving another issue, right? That is not possible to achieve with the help of IGP protocol, and this is the reason why BGP is so popular. Right? So MPLS is also solving one major issue in the service provider network, and this is the reason generally you will see the MPLS in service provider network only, because in service provider only between P to P there are lots of P routers, right? So what I want that these P router, all the P router should not check their routing table to forward traffic. This is my requirement, and MPLS is solving this. तो अगर आप MPLS आज नहीं स्टार्ट करना चाहते, टाइम भी नहीं,
यस
Okay,
थैंक
sir.
यू
Yes, sir.
सर, काइंडली आज ही वीडियो अपलोड कर दीजिएगा प्लीज।
सर सारा वीडियोस आई थिंक आपने डाल के रखा है ना स्टार्टिंग से। ओहो, एक्चुअली मैं बाहर